In this video, you will learn how to answer and solve some problems from past papers on Advanced Level Edexcel Chemistry Unit 1. This time, we will work on January 2021 paper. Which aqueous solution has the highest concentration in mole per cubic decimeter of chloride ions? So we are asked here for the highest concentration of chloride ions in mole per cubic decimeters. So this is what we're going to do. We work out moles of each solute per cubic decimeters first. So chloride ions, and then we work out moles of each of the solute per cubic decimeter. Number of moles is just equal to the mass in grams divided by the molar mass, which is in grams per mole. So we will work out the number of moles of each of the solutes here, or the compounds given. For hydrochloric acid, we're given here 0.1 grams per cubic decimeter. So that is the concentration of hydrochloric acid in grams per cubic decimeters, and we just need to convert that into mole per cubic decimeters. So we work out on the moles of hydrochloric acid. So moles hydrochloric acid is just equal to this one, the concentration in grams per cubic decimeters, divided by the molar mass of hydrochloric acid, which is 36.5 grams per mole. Then gram unit here cancels out. Then the concentration of hydrochloric acid in grams per cubic decimeter is just equal to 2.74 times 10 to the negative 3 mole per cubic decimeter. Now let's get the concentration of the second option, sodium chloride, in mole per cubic decimeter. So that would be mole. All right, it's supposed to be mole per cubic decimeters. And then we got mole here and then cubic decimeters. That's why the unit here is this one, mole per cubic decimeters. So mole per cubic decimeters of NaCl is just equal to the given concentration, which is 0.1 grams per cubic decimeters, then divided by the molar mass of NaCl, which is 58.5 grams per mole. Then gram unit here cancels out, so the concentration is just equal to 1.71 times 10 to the negative 3 mole per cubic decimeters. So these are the concentrations of hydrochloric acid and NaCl. We need to get the concentrations of all of the choices here in mole per cubic decimeters, and then we compare them and choose the highest concentration. Then we work out the next solution. Okay, the next one is potassium chloride. So number of moles per cubic decimeters of potassium chloride is just equal to 0.1 gram per cubic decimeter divided by the molar mass of potassium chloride, which is 74.5 grams per mole, then the concentration of this is just equal to 1.34 times 10 to the negative 3 mole per cubic decimeters. And for the last one, the last solution, letter D. Okay, no more space. Let me just delete this. Okay, for letter D, we have barium chloride. So the number of moles per cubic decimeter of barium chloride is just equal to the given mass per cubic decimeter, which is 0.1, divided by the molar mass of this, which is 208 grams per mole. Then its concentration would be 9.62 times 10 to the negative 4 mole per cubic decimeters. All right, now comparing all of the 4 concentrations here, for hydrochloric acid, for NaCl, this one, for potassium chloride, and then for barium chloride, HCl here has the highest concentration in mole per cubic decimeters. Therefore, the answer here is letter A. Which of these compounds has the same empirical and molecular formula? So let's check on each of the given compounds here. So the first one is C2H4. Number of atoms here, we just divide by 2. Therefore, the empirical formula for this is just CH2. And CH2 is not the same as the given molecular formula here, which is C2H4. Therefore, letter A is not the answer. How about letter B, which is C3H8? All right, so we cannot further simplify the ratio of the number of atoms here. Therefore, the empirical formula is equal to, or is just the same as the molecular formula. So the answer here should be letter B. Now let's check the other options just to be sure. So for letter C, we have C4H10. That is the given molecular formula. So it's empirical. We divide the number of atoms by 2. So that is C2H5. So it's not the same as the molecular formula. How about letter D? We have C5H10. The empirical formula of this one is just CH2. So we divide by 5. And that one is not the same as the molecular formula. So only letter B here, C3H8, has the same empirical formula and molecular formula. There are 6.02 times 10 to the 23rd atoms in 0.25 mole of any of the choices here. So we have helium, water, BH3, and CH4. So let's calculate first the number of atoms in 0.25 mole. So that is 0.25 mole times 6.02 times 10 to the 23rd per mole. So this is equal to 1.505 times 10 to the 23rd atoms. Now let's check which of the choices here, this one, has 6.02 times 10 to the 23rd atoms, given that per 0.25 mole is equivalent to 1.505 times 10 to the 23rd atoms. So let's start with option A, that is helium. So helium here, it only has one atom. So one atom. So that means this is not equal to 6.02 times 10 to the 23rd atoms. Okay, and for letter B, H2O, so this one has 3 atoms per molecule of water. So that would be 3 times 1.505 times 10 to the 23rd. And this is just equal to 4.515 times 10 to the 23rd, which is not equal to 6.02 times 10 to the 23rd. How about letter C, BH3? This has 4 atoms per BH3 molecule. So that means we multiply 1.505 times 10 to the 23rd by 4. So this is just equal to 6.02 times 10 to the 23rd. And for letter D, CH4, so this has 5 atoms per CH4 molecule. So that means we multiply this by 5. Okay. And this would give us 7.525 times 10 to the 23rd. So among the choices here, among the element and compounds given, only BH3 is equal to 6.02 times 10 to the 23rd. So the answer here is letter C. Which conversion has the lowest percentage atom economy by mass for the formation of calcium chloride? So how do we calculate atom economy? So atom economy is just equal to the molar mass of the desired product. Okay, molar mass of desired product. All right, in the problem, given problem here, formation of CaCl2. So that CaCl2 is our desired product. Then divided by the total molar mass of reactants. Mass of reactants. Then times 100%. That is percentage atom economy. So how do we do this? All right. Okay, so we get the molar mass of CaCl2 first, and then we get the total molar mass of the reactants in each of the options here. Okay, molar mass of CaCl2, so that is just 1 atom of calcium plus 2 atoms of chlorine. This is just equal to 110.98 grams per mole. And now we do this one by one, so each of the options. So let's start with option 1. Option 1's reactants are calcium and 1 mole calcium and 2 moles chlorine. So that means the molar mass of these reactants is just equal to the molar mass of CaCl2. So our atom economy would just be equal to the molar mass of CaCl2, which is 110.98 grams per mole, divided by the molar mass of Ca plus Cl2, which is also 100.98 grams per mole, times 100%, and this gives us 100%. And then for letter B, desired product is CaCl2, right, this one. So that is, okay, letter B, atom economy is equal to 110.98 grams per mole, divided by this one, the molar mass of the reactants. So that is the molar mass of calcium plus 2 times the molar mass of hydrogen plus 2 times the molar mass of chlorine, which is just equal to 112.996 grams per mole times 100%, and that would give us 98.22%. And for letter C, okay, atom economy of conversion C. So that is 110.98 grams per mole divided by the total molar mass of the reactants. The reactants here are CaCO3, calcium carbonate, and 2 moles of hydrochloric acid. And that is just equal to 173.006 grams per mole times 100%. That would give us 64.15%. And the last one, letter D, so atom economy is equal to the desired product CaCl2, or the molar mass of that, which is 110.98 grams per mole, divided by the total molar mass of the reactants. The reactants here are 1 mole of CaCO3 plus 2 moles of NaCl, and that is just 216.97 grams per mole times 100%, and this would give us an atom economy percent or percentage atom economy, which is 51.15%. And now we are asked for the lowest percentage. Among the 4 choices, letter D has the lowest atom economy. So the answer here is letter D. Which of these atoms has the most neutrons? All right. So to calculate for the number of neutrons, we just subtract the mass number and the atomic number of the isotope. So that is mass number minus atomic number. Now let's start with option A. Option A, we're given here indium with atomic number 49. 49 and mass number 115. Okay. So number of neutrons here is just equal to the mass number, which is 115, minus 49. So this is 66. For letter B, we have tin with atomic number 50 and 124 mass number. So this is just 100, okay, neutrons, number of neutrons is equal to 124 minus 50. This is equal to 74. And then for letter C, we have antimony with atomic number 51 and mass number 123. So the number of neutrons is just equal to 123 minus 51, which is equal to 72. And for letter D, we have tellurium with atomic number 52 and mass number 124. So number of neutrons here is just equal to 124 minus 52, which is equal to 72. So among the given isotopes or atoms, tin, the isotope of tin, has the most neutrons. So the answer here should be letter B. A p-block element in period 3 of the periodic table reacts to form an ionic compound. What could be the electronic configuration of the ion formed by this element? So we are asked for a p-block element. So that means the end of the electronic configuration is in the p subshell. Element in period 3 of the periodic table, this forms an ionic compound. Now let's identify first the p-block elements in period 3. So that would be from sodium, which has an atomic number of 11, to argon, which is an inert gas with atomic number which is equal to 18. So these are the elements. We have, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. And then we write each of the electronic configuration of the elements. So for sodium, with atomic number 11, so this is the same as neon, so this is 3s1. And then for magnesium, with atomic number 12, still the same as neon, this is 3s2. And then for aluminum, the same as neon, this is 3s2, 3p1. Yeah, and then for silicon, this is 3s2, 3p2. And then for phosphorus, that is 3s2, 3p3. And then for sulfur, that is 3s2, 3p4. So you can write this. Now I'm only writing here the shortened one. You can use the Aufbau principle to write the electronic configuration, the expanded one. Then we have chlorine. This one is 3s2, 3p5. And then we have argon. Argon is 3s2, 3p6. Alright, so these are the elements in the p-block elements in period 3. Now the question is, which of these elements reacts to form an ionic compound? So what is an ionic compound? Okay, when we say an ionic compound, this is a chemical compound that formed when metals transfer electrons to non-metals. So this would create oppositely charged ions that are held together by strong electrostatic forces of attraction. Now among the elements here, from sodium to argon, only aluminum Okay, let's encircle the aluminum, phosphorus, sulfur, and chlorine form ionic compounds. So aluminum here forms alumina or aluminum oxide. Then phosphorus forms sodium phosphide. Then sulfur forms sodium sulfide, and chlorine forms sodium chloride. Now let's write the electronic configurations of these four elements, and then we compare with the choices here. Then we choose. Right, for aluminum 3 plus, this is 1s2, 2s2, 2p6. And then for phosphorus, 1s2, 2s2, 2p6, 3s2, 3p6. And then for sulfur or sulfide, this is 1s2, 2s2, 2p6, 3s2, 3p6. And then for chloride, this is 1s2, 2s2, 2p6, 3s2, 3p6. Now let's choose. Which among these four elements, or which of the electronic configurations of the four elements are or is present here in the choices? Right. So I think it's letter B. 3s2, 1s2, 2s2, 2p6. So I think this one. Okay. So the answer is letter B here. The period 2 element with the highest melting temperature. So let's recall which elements are in period 2. So period 2 runs from lithium, okay, lithium to neon. Okay, lithium has atomic number of 3 and neon has atomic number of 10. So these elements in period 2 are lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Okay, let's check the choices here. Aluminum is not in period 3, so that one is not included. No, period 2 rather. Okay, silicon is not in period 2 either. So we will just choose between boron and carbon. So we only have boron, boron B, and carbon C. So we are asked here which one of these two has the highest melting temperature. So let's compare their melting point. Boron's melting point is 2076 degrees Celsius. And carbon can be from diamond, can be diamond or graphite. So its melting point sublimes at approximately 3550 degrees Celsius. So which is very high, which is much higher than that of boron. Therefore, the answer here should be carbon. Which of these has the greatest electrical conductivity? So how do we know whether an element or a compound is a great conductor of electricity? Now let's talk about the types of conductivity first. All right, so we have metals. Okay, metals, of course, they conduct strongly both in solid and liquid states. This is mainly because of the presence of the localized electrons. And then we have, okay, that is the first one. The second one, we have ionic solids like sodium oxide. So what are ionic solids? So that means they do not conduct electricity in solid state, but they do conduct when molten or dissolved in water. And the third type is covalent solids like diamond or silicon dioxide. Covalent solids, which are poor conductors of electricity, except graphite. Now that we know the types of conductivity, let's analyze each of the options here from A to D, if whether they are metals, ionic solids, or covalent solids. Okay, the first one, we have SF6 or sulfur hexafluoride. Okay, sulfur hexafluoride in its gaseous state, this is just simple covalent molecule. So that means this does not conduct electricity. So this is non-conductor, since it's neutral and no ions. And how about the second one, which is water in liquid state? Pure water has extremely low conductivity, only self-ionizes very slightly into H3O plus and hydroxide OH minus. So it's basically an insulator unless there is the presence of impurities or ions. So water here is also a non-conductor. And then for letter C, we have mercury. Okay, mercury is a metal and it is in its liquid state. Okay, then we have sodium dioxide in its solid state, but this is a covalent solid, and they do not conduct electricity in its solid state. So that means Na2O is a non-conductor of electricity. Therefore, among the choices here, mercury has the greatest electrical conductivity. So the answer here should be letter C. Which of these ions has the greatest ionic radius? So what are the rules for ionic radii? Right, for cations, these are the positive ions. Okay. The radius for this is smaller than their atoms. And they lose electrons. So less repulsion, higher effective nuclear charge. And for an ions, these are negative ions, which means their ionic radius, radii, are larger than their atoms. And they gain electrons, which means more repulsion and lower effective nuclear charge. And then we can conclude here that the higher the charge, the stronger the effect, and the smaller the radius or ionic radius. Now let's compare the choices here. Compare each ion. So we have nitride and 3 minus. Okay, this gains 3 electrons. Gains 3 electrons. And then for fluoride, this gains 1 electron. Then Na plus sodium ion, this loses 1 electron. And aluminum ion loses 3 electrons. So again, from the general rules for ionic radii, higher charge means stronger effect or stronger effective nuclear charge. And that also means smaller ionic radius. Among the choices here, aluminum has the highest charge. Then next is sodium, fluorine, then nitrogen. So the one with the smaller charge here is nitrogen ion. Therefore, it has the largest ionic radius, and we are asked for the greatest ionic radius. So the answer here should be nitride. So that would be letter A. Which of these ions has the greatest polarizing power? So what is polarizing power? Now, polarizing power of a cation or polarizing tendency of an ion is the ability to distort the electron cloud of the opposite ion. We have these rules, Fajans rules. So small cation, small cation with high charge. So that means it has high polarizing power, while large ion with high charge doesn't have any polarizing power, but it has high polarizability. Now let's evaluate each of the ions given here in the choices. This one. So the first one is we have sulfide. This is an anion. Therefore, this is not doesn't have a polarizing power. Then we have chloride. Again, this is an ion, so not polarizing. This is polarized. And then we have potassium ion. This has +1 charge. Therefore, it has a large radius. And then we have calcium ion. Okay, both potassium ion and calcium ion here are cations. So this has a +2 charge, which means the radius of this is smaller than that of potassium. Again, let's recall that small cation with high charge has high polarizing power, while large anion with high charge doesn't have any polarizing power. So in this case, we will only choose between potassium and calcium ions. Now potassium has +1 charge but large radius, and calcium has +2 charge but small radius. Therefore, the one with the greatest polarizing power here is calcium ion. So the answer here should be letter D.